So today we're going to talk about synthesis and decomposition reactions. And so if you get your sheet out that has your notes on it, this is reaction type 4 and 5. I don't know why that says 2. It should say 5. And we're going to go through the first four types of each, because synthesis and decomposition can be broken down into a couple different types. A through D is what we're going to go through today. Luckily, the synthesis is exactly the opposite of decomposition, so it's really only learning 4 new things, but learning them kind of both ways. The simplest type of synthesis reaction is just 2 free elements coming together to form a binary compound. So if we had magnesium plus oxygen, those are 2 free elements, and they would come together to form the binary compound, magnesium oxide, and then you would just write the formula based on the charges. So 2 plus magnesium, 2 minus oxide, so it's just MgO in a 1-to-1 ratio. We do have to balance. So to balance the balance the oxide with the oxygen on the other side, I'm going to put a 2 in front of magnesium oxide and then a 2 in front of magnesium. So those are pretty simple. It's just a matter of writing one formula with the correct charges and then balancing. Okay, the next thing that can happen is a little less predictable, but you just kind of have to remember how this works. A metal oxide plus water yields metal hydroxide. So a metal oxide is just a metal paired with oxygen. So for example, if you had sodium and oxygen paired together, sodium oxide, that's an example of a metal oxide. But it could be any metal. And then we're going to add it to water. And it's not quite as intuitive what's going to happen here, so you just kind of have to memorize this. But whenever we have a metal oxide in water, we're going to get a metal hydroxide every single time. Okay, so we're going to get, in this case, the metal, of course, is still sodium, so it's going to be sodium hydroxide. And again, because of charges, +1 and -1, sodium is +1, hydroxide is -1. We're going to get just one of each. So then balancing wise, it looks like I have 2 sodiums on the left, as well as 2 oxygens, but by putting a 2 in front of sodium hydroxide, it looks like that balances everything, because now I have 2 sodiums, I have 2 sodiums over here, I have 2 oxygens, 1, 2 oxygens, 2 hydrogens, 2 hydrogens. Okay, so that's the second type of synthesis reaction. So for C, metal oxide plus carbon dioxide, very similar. So metal oxide is, I could use sodium oxide again if I wanted to. I'll just change it up a little bit. Let's say we have aluminum oxide. So that's going to be Al2O3. And then carbon dioxide, of course, is just CO2. And so it's going to make metal carbonate. And in this case, the metal is aluminum. And so we're just going to pair that aluminum with carbonate. So Al2CO3 balances the +3 charge on the aluminum and the -2 charge on the carbonate. And then we just balance the equation. So it looks like on the right we have 9 oxygens, which is kind of weird, because on the left we have 2 in the CO2, and we have 3 in over here with the O3, or the Al2O3. So one thing to do would be to say, okay, let's balance the carbon. That sounds simpler, and let's just see if the oxygen kind of works out. So right now I have three carbons on the right, so I'm going to put a 3 in front of CO2 on the left and see what that does. Okay, that gives me 3 times 2 is 6 oxygens on, here, plus these 3 is 9, and that in fact does balance out my oxygens. So it's all set. Next up, metal chloride plus oxygen yields a metal chlorate. All right, so again, you just kind of have to recognize these, memorize them, however you want to say it. But a metal chloride, just pick a metal basically. Let's say we have iron 2 chloride. So FeCl2 plus oxygen is going to yield a metal chlorate. And in this case, the metal is the same one that we have on the left side, of course, which is iron 2. So we're going to get FeClO3, you remember, is chlorate, and then there's going to be 2 of them because the iron has a 2+ charge. and then it looks like our chlorines are balanced, our irons are balanced. It's our oxygens. We have 6 on the right, so I would go ahead and put a 3 in front of O2 on the left, and I think we're good. Okay, and then so with decomposition, as I said, it's kind of like learning. It's kind of like a 2-for-1 because we learn these 4 reaction types, and synthesis, which I didn't say this yet, but synthesis reactions tend to be exothermic, and that's because compounds that they're forming tend to be more stable than the reactants that they're made up of, whether that's a free element or a metal oxide and water. But the end result is typically more, it's lower in energy than the reactants were, so you give off that energy in the form of, fire or a little bit of heat. Now, decomposition, synthesis is making something, decomposition is breaking something down, so it's just the exact opposite of what we just talked about. So if I look at, free element plus free element makes binary compound is synthesis A. Decomposition A is binary compound plus, breaks down into free element plus free element. And so, we can just work in exact reverse. So binary compound, let's say we have, let's say cobalt 3 nitride, so CON. And so that's going to give us cobalt, and it's going to give us nitrogen. We would just have to make sure that we remember that's diatomic. It's a Brinkelhoff. And then we just have to balance with a 2 in front of cobalt 3 nitride and a 2 in front of cobalt. Metal hydroxide breaks down into metal oxide and water. Again, it's just the exact reverse of the reaction up above. So this time I'm starting with the metal hydroxide. So let's say it's calcium hydroxide. So that's going to give me calcium oxide and water. Okay. So that's going to give me, I'm going to have two hydrogens on the right. I have 2 oxygens on the right and 1 calcium, and it looks like that's the case on the left as well. And then C, metal carbonate. So pick another metal. We'll go with let's go with copper this time. Let's go with copper 1 carbonate. So that's going to give us a metal oxide. We keep the charge on copper the same. So if it's copper 1 and it's paired with oxide, it's going to be Cu2O and carbon dioxide. And it looks like this time it's already balanced, right? So we've got everything's 1 to 1 once again. So not 1 to 1, but copper, we have 2 coppers on the left, 2 coppers on the right, 1 carbon on the left, 1 carbon on the right, and 3 oxygens on each side. So then finally the last one, again, just like synthesis D, only in reverse. Start with a metal chlorate this time. And so let's go with potassium chlorate. So KClO3, and that's going to give us a metal chloride, which would be potassium chloride, and it's going to give us oxygen. And so then we just have to balance. So my oxygens are not balanced, so I have to put in a 3 on the right, a 2 on the left, and then a 2 in front of KCl. So you have to know those 4 types, especially B, C, and D are just kind of memorization, although they do kind of make sense, that a carbonate would always give you carbon dioxide, or that hydroxide might lead to water, because of course they have those elements in the compounds. So we'll talk more about these and get a little bit more practice next time, as well as going over the last 2 types of synthesis and decomposition.